It's recording.
Hi, Tori!
Oh,
Hi,
man.
Tori!
Okay, all right.
Tori. We miss you. Yeah.
So here's the deal.
Yelling my name for?
Section 6.6. All right, so you got to really be involved in the next 15 minutes because this is going to be important, all right? So there are properties. Well, this should be done maybe in 15 minutes if we're quiet.
Sit your butt down.
6.6. Properties of logs, okay? Algebra 1. In Algebra 1, you guys probably didn't do logarithms ever before, okay?
No.
So you don't know how to compute stuff with logarithms, all right?
I know what that means.
I have a log. Shh. All right. Shh. Okay? You don't know how to compute with logs, right? But I'll tell you the rules of what you can and can't do when you're adding, subtracting, multiplying, dividing logs, and then it's just basic from there, okay? So there are rules for logarithms, putting stuff together, and one of the rules says this.
Right.
This is the product property, okay? What does product mean?
Answer.
Nope. What's product mean?
Oh. The answer to multiplication.
Okay, so multiply, okay? Product means multiply. Now, I'm going to put multiply equals add, okay?
But it
When it tells you multiply, you are going to add, and here is why, okay? I'm going to relate this back to something that you've seen before. So let's say I have x squared times x cubed, right? X squared times x cubed. We are multiplying there, but what do we do with the exponents?
Add.
You add. That's why multiply means add. Do you see that? Okay? Now, if we have two logs and we're trying to add them, so I'm going to flip here to logarithms. Let's say I have log base 2 of 4 and I'm adding it to log base 2 of 8. Okay? In this case, we're trying to write it as one log. Okay?
So
and what are you going to multiply? It will stay log base 2, but you're going to multiply the 4 and the 8 together. Right? You're going to multiply the 4 and the 8. Okay? So what will become is a log base 2 of 32. That's how you will put them together. Okay?
What happened to the other log base 2?
Okay? Now, I'll review. Okay? Up here, when we were multiplying, this was a multiply. And what we did to the exponents was add, right? Multiply made add. This one, we are adding the two logs, and together they become one log, but instead of taking 4 and 8 individually, you are multiplying the 4 and the 8 together.
Wait.
So here, add becomes multiply. Do you see that?
So then, what if the logs aren't the same number? Yeah.
If the bases are not the same, you cannot put them together. They won't do that to you. They will only give you ones that are the same basis.
So we won't have any.
You won't have any weird ones. No.
Okay.
So they will only ever be the same base. Okay. Now here's my question to you. Here we had two of them that we were multiplying together, and multiply made add, right? 2 became 1. Multiply became add.
Yeah, but
Why is it the opposite here, where add becomes multiply?
Because it's an inverse.
Yes, exponential functions and logarithm functions are inverses. So here, when we're adding functions together, we actually multiply to make 1. Here, when we're multiplying as 2, we add to make 1. Does that make sense?
Yeah.
Okay, so let's go down here to this example. We have these two pieces, and we are adding them together. Circle that plus sign. Get used to that. Circle the plus sign. Anytime you have two logs and you want to put them together, you look for this symbol in the middle. And add means multiply, okay? So I want to write this as one log. What will the base of the log be?
4.
4?
Log base 4 of 64.
I'm writing 64. Log base 4 of 2 times 32 is
64.
log base 4 of 64. Now, they want us to simplify. So there's one more thing they want us to do.
Because
in addition to that, okay? So I want to solve for log base 4 of 64. So I'm going to set it equal to X. Okay. Shh. And what this guy means is 4 to the X power equals 64, right?
What?
If I make him an exponential function, right? If I switch him around and make him exponential,
I didn't think
4
we were
to the
supposed to
X
do
power
that.
equals 64, and then how many times do I take 4 times itself to get 64?
3.
3. So X equals 3. That's my final answer. Right?
Wait, so you are
So
gonna
you're ultimately
switch on?
solving for x, but
Yeah.
you have to turn it into
Basically,
exponential.
yes. So these guys, these two pieces together make just an answer.
Wait,
of
are
3,
we
and that's
learning
it.
how to subtract today?
Yes, we will.
Oh,
Okay.
no.
All right. So Now, they're going to do something else to you in part B, and I'm going to change this guy right here on your notes, please, and make that log base 4 of just 9, not 192. We'll start off with something easier, okay? So in your notes, really quick, change this. In your notes, really quick, change this. Log base 4 of 9 instead of 192. Do that really fast, okay? That's what we're solving for. All right, they're giving me an answer. They're saying that log base 4 of 3 is that number, right? Okay? And what I want to find is log base 4 of 9, all right? Now, log base 4 of 9 is what we're starting with, but can I write that in terms of 3?
Yeah, what?
Like, what is 9 in terms of 3?
3 squared.
Right, 3 squared, or 3 times 3, right?
Yeah.
That can be written as log base 4 of 3 times 3, right? Now, up here, we were taking 2 logs and we were adding them together and making 1 log, right? Here, if I take these and split them apart, log base 4 of 3 times 3 will become log base 4 of 3 plus log base 4 of 3, okay? Because multiply means add, so if I'm breaking him apart, he becomes 2 logs, but I'm plussing in the middle. Does that make sense? Yeah?
No.
3 times 3 multiply means add,
So
right?
like it's
So
almost
it's
like
log
factoring.
So it's doing this step in
like
reverse.
weird.
Like this right here, the 2 times the 32 was the same thing as log base 4 of 2 plus log base 4 of 32, right? I'm going back the other direction and splitting them apart.
Wait,
instead
I
of
don't
putting
like
them
that.
together.
Oh, so it's like it kind of looks like that.
Okay. Right, kind of, yes, okay. Now, the wonderful part about this is I know what log base 4 of 3 is, right? What is log base 4 of 3?
9.
No?
What?
What do they tell me
Oh,
log base 4 of 3 is?
0.7925.
0.7925, right? Okay, and what's log base 4 of 3 over here?
Same thing.
0.7925, and what am I doing to those two numbers?
Multiplying them.
No, now I'm adding them,
Oh.
right?
What? Adding.
Right? I'm adding them together. So, 0.7925 plus another 0.7925 is what?
Wait. No, 1.
Wait. 1.585.
1.585. This is what we have here, okay? And that's it. That's all we have to do. So what we're
I don't like
gonna
that. That's
do,
confusing.
just wait. We'll do another one and you'll be like, okay, that makes more sense, right? Okay. So they give me the answer to log base 4 of 3. Just reviewing this problem. They give me the answer to log base 4 of 3 and they say, okay, now find 9. Okay. Well, 9 is just 3 times 3, right? But when we're multiplying, that means we're adding, right? So I'm just taking this and adding it to itself again. So this plus itself makes that.
What
Yeah?
if it didn't tell you that 3 is? What if it didn't tell you that it equals?
They will give it to you.
Okay.
They have to give that to you. Yes. We're going to do another one down here, but this one's going to involve division, okay? So, quotient. Quotient means divide. And what do you think divide means?
Fraction.
Subtract.
Oh, dang it. My bad.
Okay? So, I relate this back to exponential functions again. Let's say I have x to the 5th power divided by x to the 2nd power. What's that make?
What? X to the 3rd.
X to the 3rd. Why? Because you subtract the exponents, right? You subtract those exponents, okay? Now, same thing here. If I have a log base 2 of, let's say, 8 minus log base 2 of 4, and I want to put those together. I want to put those together as one log.
So it's log base 2.
Log base 2 of,
8 minus 4.
nope,
8 divided by 4.
8 divided by 4.
So it's 2.
So minus means divide. So I'm dividing the 8 and the 4. So he just simply becomes log base 2 of 8 divided by 4, which is
2.
log base 2 of 2. Okay? Does that make sense?
Wait.
Yeah? Minus means divide. Take a look at it. Minus means divide. Okay? As soon as you learn these rules and you understand them, you're like, oh, that's not too bad. Oh, that's pretty easy.
Oh wait. We're doing.
Okay.
Which one were we doing?
Okay?
I
I
just got
just made that up. I just made that up, Emma.
Oh,
That's
okay.
a made up example. This is a made up example. Now we're going to do this one over here. Okay? So we have this guy, and then we have a minus in between them. But minus means divide. So when I put those two together, what will be the base? Log
2.
base 2. And what are we dividing?
32 and 4, so it's 8.
32 divided by 4.
Log base 2 of 8.
So it will become log base 2 of 8.
Okay, that
Okay.
makes more sense than the
Right.
stupid one where you had to split it backwards.
Okay, just wait.
before.
Okay, now hold on, we're not done yet. We have to simplify. Equals,
So,
Equals?
2 to the x power equals 8.
x.
What?
Okay, do you want to go?
No.
Okay, then shut up.
2 is the starting.
2
Okay.
to the x power
Equals
8.
8. So I'm taking this guy and I'm flipping him around and he becomes this.
And then
2 to the x power equals 8.
That's 3.
3.
And it, x
Equals 3.
X equals 3. There you go. Okay,
So I have a question.
alright.
On whenever we're doing using the quotient properties, will they ever be like not good numbers in there?
No.
It'll always
be.
Should be. Should be. Yeah. So minus means divide. So again, I'm going to go through this. These two subtraction means I want to put them together as 1, but I'm going to end up dividing those two last numbers, right? 32 divided by 4 was 8. And then we just figure out what that number has to be. So 2 to the x power is 8, and 2 to the third power is 8, so x is 3, right? Okay? All right. Let's do this. Let's say that in some, let's say I have this going on. Log base, let's go log base 5 of 2 to the third power. Okay? Write this down. This is a made-up example, but I'm going to show you how this works.
Oh, I don't like this.
Okay? Log base 5 of 2 to the third power.
I've seen
you're gonna
this.
like this one. You're
I've
gonna like
seen
one.
this before. I don't think I like it.
Log base 5 of 2 to the third power. Okay, this means log base 5 of 2 times 2 times 2, right? 2 to the third power means 2 times 2 times 2, right?
Yeah.
Do you agree? Yes? Okay. Now, multiply means what?
Add.
Add.
Not divide,
So what I can do is I can split this apart into 3 pieces, which becomes log base 5 of 2 plus log base 5 of 2 plus log base 5 of 2. You see what I just did? Okay, 2 times 2 times 2, I split them apart into 3 pieces, log base 5 of 2, log base 5 of 2, log base 5 of 2. Now, how many, if I combine like terms, how many of them are there?
3.
3 of them. This could be written as 3 log base 5 of 2. Okay, do you agree? Does that make sense? There are 3 of them. All right?
So then we
So,
have to.
look at what we just did. Look at what we just did. We said that log base 5 of 2 to the third power is the same thing as 3 log base 5 of 2, because this rule right here says that if I have this 3 up at the top, he will come down in front and
Will
he
it
can be a
always
3.
like that?
It will
So,
always
like,
be
if
like that.
There's an exponent, you can just pop it.
Right. So if there's an exponent ever here, you can always just plop it down in front. Okay, now, that's a little bit different than something we've ever done before, because is it true that this 2 on x squared can come down in front and make 2x?
No.
No, but in log world, that's true, right? That 2 will come down in front, or that 3 will come down in front, okay?
What are you
Because
doing?
of that reason, okay? Because of that proof off to the side, that's why that will work, yeah? Okay, because of that proof off to the side, that's why that will work. Okay, so they are wanting us to do this, okay? This simplifies our life a little bit, since we know this rule.
So do we not have to solve that?
Well, this was just showing you how that property worked, okay? So we're not going to solve anything further on that one. Let's go to this one and let's see what this
So
becomes.
it's 2 log.
Okay? So this guy right here, here's my options. 81 to the second power. That's a really huge number, and I don't want to deal with that. Okay, so that 2
Plops in front.
plops in front. So let's do the 2 plop in front. So here he comes down.
2 log
2.
base of 3.
Log base 3 of 81. Okay? And I'm gonna put him in parentheses like that, right? The 2 can come down in front. He looks like that. Now, can we figure out what log base 3 of 81 is if we set it like equal to x, right? Equals x, if we do that. Log base 3 of 81 means 3 to the x power equals 81, right? If I change him to exponential. Okay, 3 to the x power equals 81, what does x have to be? Just wait. We'll fix the 2 here in a second. 3 to the x power equals 81. What does that mean? X equals what?
Oh wait, no. 4, 5, 6, 7.
How many times do I take 3 times itself to get 81?
4.
4. Okay. So that means this whole thing right here is 4. Right? That whole
But
thing
take
right
half
there
of
is
it,
4.
so it's 2.
No.
Dang it.
We're multiplying 4 by? What's out in front?
2 log.
2 and 4 make?
By log.
8.
We're multiplying it by log.
Okay?
Oh no!
Okay? All right, so let's review what we just did. Okay, this looks a little foreign. These are not hard concepts, but you've never done this before, right? So the 2 can come down in front, and then we said log base 3 of 81 is 4, because we solved it. So 2 times 4 just gives me 8, and that's it.
Wow.
Right, so the answer
Get
is
out.
8.
Get
What
out.
are you doing in here?
So the answer is 8. All right. Okay, hurry up and get up. I'm recording. Go. Go.
Recording.
Go.
It's to Tori. Tori is not gonna watch this.
All right.
No, she won't.
Okay.
She actually won't.
So part B. This is another one of the weird ones that you didn't like before. They tell me that log base 2 of 5 is 2.3219, right? Okay. Sit down. Log base 2 of 5 is 2.3219, right? Whatever that number is. Okay. They want to know what log base 2 of 25 is. I'm going to rewrite it because my numbers are getting all clogged up here. Okay. So they want to know what log base 2 of 25 is. I know what log base 2 of 5 is. They want log base 2 of 25. Yeah. Okay. Now I want to write. I want to write log base 2 of 25 as something, right?
So x.
So we could say that log base 2 of 25 is the same as log base 2 of 5 squared, right? We could do that, right? Isn't 25 the same thing as 5 squared?
Yeah.
Okay. I can put them in parentheses, which makes me feel better, right? Okay. But then what does that do? What can I do from here? If I know that 25 is 5 squared, what can I do with that 2 on the top?
Flop them around.
Plop him down in front, right? This 2 can come down in front. So now it's 2 basically times log base 2 of 5, right? But do I know what log base 2 of 5 is?
Yes.
Yes, it
So
is that decimal, right?
2.3
2.3219, and what do I do with that?
times 2.
Times 2, and that will give me my answer.
4.6438.
4.6438. Does that make sense?
Yes.
That's how I do it, right? Good?
Yeah.
Okay. Another thing that I could do, okay, don't write this down if it confuses you, but we could also say that log base 2 of 25 is equal to, watch this, log base 2 of 5 times 5, right? Like we did up above. But what does multiply 5 times 5 mean? Nope. If I make them two things, log base 2 of 5 and log base 2 of 5, what goes in between them? Well, kind of, yes, but what goes in between them? Multiply means? Add, okay? So in that case, I'm just taking 2.3219 plus another 2.3219. Am I going to get that as an answer?
Yes.
So that's another way of thinking about it. Instead of thinking about it as 5 squared, it's 5 times 5, yeah? And then making it plus. Good? Okay, let's go to the next page. All right, these two are kind of... What?
Are
All right.
Fast?
These are kind of... Example 4 is a little bit longer. Example 5 is really fast.
Oh,
Okay.
that doesn't look fun.
All right, example 4. Here's my equal sign. Okay? And I have these 3 pieces. Okay? Those 3 pieces. The 2 is kind of chilling out. He has nothing to do. He just is we're just going to wait on him. But these 2 logs, I want to put them together. What's in between those 2 logs?
Log base.
Nope. What's in between these 2 logs?
A plus.
A plus. Okay, circle the plus. Okay, in between those 2 logs is a plus. In between those 2 logs is a plus. What does plus mean?
Multiply.
Multiply. Add means multiply. Okay, so when I make them that, I'm going to put them together as 1, right?
Log base 6 of
And what am I multiplying?
x and x minus 9.
Okay, I'm multiplying the x and the x minus 9. Okay, if I multiply those together, what do you get? What's x
6
times x minus 9? Nope, no. What's x times x minus 9?
X squared.
X
minus
squared
9x.
minus 9x. Do you see that? I put those together and multiply the 2 end pieces, x and x minus 9, right? Those 2 are getting multiplied together. Equals?
X. 2. What's my
2,
bad?
he's just chilling out, right? The 2's just hanging on, right? So what we've done is we've taken these 2 logs and we've put them together, yeah?
Yeah.
Which we've done by multiplying. Okay, now, let's take this and let's make this an exponential function. Okay.
How do you do that?
All right? Make it an exponential function. So what's the base going to be?
6.
6 to the
X 2.
2 equals?
X squared minus 9x.
X squared minus 9x. 6 to the second power equals x squared minus 9x. Okay? What is 6 to the second power? Let's fix that.
36.
36. Okay? All right, now, we want to solve for x.
So x minus 1.
Let's do this. Let's bump the 36 to the other side.
That's what I did.
That's what you did? So I have 0 equals what?
What? Oh.
X squared
Okay. Minus 9x minus 36. You betcha. That's what he looks like. Yeah? Okay. Now, what can I do with x squared minus 9x minus 36? We're almost done.
Divide 9.
No. That's a
Divide by
trinomial.
2.
That's a trinomial.
Break it down.
So we are factoring.
We are factoring. So, what can you multiply to get 36, but when you add them, give you negative 9?
6.
12 and 3.
12 and 3, Emma says. Which one is negative?
It's gonna be the 12.
Yep, the 12, and this is positive 3, okay? So, if I set this one equal to 0, if I set x minus 12 equal to 0, what's x equal to?
X equals 12, x equals negative 3.
You betcha. There we go. So, in this case, I have 2 answers, because I end up factoring, yeah? Are we doing okay? That was a long problem. Now,
Wait,
here's a short problem.
so will you always have 2 numbers if it has?
All right, we're gonna come back to this problem here in just a second because I'm gonna show you there's something that you have to do. Okay. All right, now this one, example 5. I'm gonna skip the property and go straight down to number 5. But let's talk about something over here. Here's my example. Let's say I have log base 2 of x equals log base 2 of 5. If I have log base 2 of x equals log base 2 of 5, what's x equal?
What? I don't know.
If I have log
5.
base 2 of x equals log base 2 of
5.
5, x has to be 5, right? Like basically 5 is this number, right? Or in other words, it helps you to think about it like in exponential functions, if they're the same number, those things can cross out, right? Does that make sense?
Yeah.
X would be the same thing as 5. Okay, now, that's the same thing for this example right here, except
So
what's in
x
my
equals
way? Just wait.
16.
What's in my way?
The 2.
The 2. This 2, before I
So
can
is it
cross my
8?
log, just wait a second. That 2, before I can cross things out, needs to go somewhere.
Divide by 2.
No, we can't divide by 2.
Why?
Because the 16 is stuck to the log, and we can't divide him by 2. But where can that 2 go?
Over the x.
He can go back to the back, right? This guy can go back to the back here. So this is a 2 right there, okay? So let me show you. Log base 7 of x squared equals log base 7 of 16.
Wait,
That
so
2
then
just went to the
x
back.
equals 4.
You're close. You're close. Okay,
Wait,
so
why?
that 2 is out of the way.
So
Just
then
wait a
x
second. Just wait a
squared
second.
equals
Just wait a second.
7.
Just wait a second. You're almost right. Okay. So do you see how that 2 went back to the back, right?
Yes.
Okay. Now the logs go away. Log base 7. Log base 7. So I have x squared equals 16. How do we get x by itself?
Square root.
Square root. What's the square root of 16?
4.
You're close. Who inserted the square root?
Plus
We did.
minus.
Positive and negative 4. Okay, so write that down, but here I'm going to tell you something real quick. Log functions, the graph of a log function never is negative. Okay, if you try to type something into your calculator and take log of a negative number, it doesn't work. So we have to cross out all of the answers that we get that are negative when we're solving for x. So the only answer here should be
X equals 4.
x equals 4, right?
So I was right.
You were right. Yes. Yes. Okay. Now, taking that into consideration, above the problem that I just got done with, the one that I just got done with at the top of the paper,
It's negative 3. You can't have that.
you can't have negative 3.
Oh my goodness. That's why
So
we're
the only
coming
answer
back
I
to
get
it.
was 12, right? Okay. So when you're solving for x, logs can't be negative. So any of the time that you're solving for x and you get a negative answer, that's not good. You cannot do that. Okay. All right.
You made up that rule.
If you're watching this video and you don't have the homework and you didn't get it from me, whatever, we're doing odds on both sides. So there you go.
Craig, get this out
When
of
you
my
come get this
face.
stuff from me, odds on both sides, there it is.
Is that a vape?